As usual, I show you the paper and see the figure and table and go to the my slide, PPT slide. The title is Temporal Trend and the potential drivers of stranded marine debris on beaches within 2 U.S. national marine sanctuaries using citizen science data. Is published in 2020 by U.S. NOAA scientists by Amy et al. It's about shoreline monitoring data. They have good program. It's called NOAA MDMAP, and they analyzed archived data from 2012 to 2019. I'll read all of the abstract for your understanding. Marine debris is a threat to our ocean that can be more effectively addressed through monitoring and assessment of items stranded on the shorelines. Today, engaged in science, this study engaged citizen scientists to conduct the shoreline marine debris surveys according to a published NOAA protocol within the Great Polarons and Olympic Coast National Marine Sanctuaries on the west coast of the United States. Here, we use the data of these multi-year monitoring data to estimate marine debris abundance and temporal trend, identify drivers of marine debris loads. Changes in debris count and composition are shown to reflect seasonal patterns of coastal upwellings and downwelling, but longer temporal trend in overall debris loads depend on the sampling window. Identifying drivers of stranded debris is challenging given the observational nature of the data. A linear increase in total expected debris counts was observed when up to 5 participants are conducting a survey, suggesting a need to standardize the number of participants and their search pattern for debris in shoreline monitoring efforts. Lastly, we discussed the application of shoreline marine debris data to evaluate the impact of management decisions and identify new targets for mitigation. So they used two data sets from 2 regions, 2 national marine sanctuaries. One is from Greater Polarons National Marine Sanctuary. The other is Olympic Coast National Marine Sanctuaries. The coastal area of California and Oregon. I'll show you the map. This is the map, and more, a broader area we can see here. And this is Washington State, and this is California State. And this is Great Polarons. They are located in this lower scale, and Olympic Coast locates in the upper scale here in the Washington State. And from here, 26 accumulation survey site was selected, and from here, 6 survey sites were selected, 4 for standing stock survey and 2 sites for accumulation survey. Then we'll see the tables. Table number 1, summary of a final negative binomial model is the result of the model for total debris count during accumulation surveys in 2 regions. Because standing stock survey was not conducted in Olympic Coast National Marine Sanctuary. And as you see, we have many variables for the model. They developed the model from the debris data. And just so we can see the p-value, we just see p-value and is lower than 0.005. This term, these variables are significantly important. For example, p-value is very small, lower than 0.005, then this type of the debris is important, significantly different between types and between seasons, between two sanctuaries, and tidal lanes, river input, and interaction between type and season. I'm telling this, and interaction between type and sanctuary and the season sanctuary and the initial survey days since prior survey. It means how many days has passed from the initial survey for accumulation data, because we have to remove the data for accumulation survey. So how many days passed? They considered the days as variables, and types, sanctuary, and survey year. Then these terms was significantly important for the total debris. Yeah, I'm sorry, I have to omit this because it's not lower than 0.05. And for smoother term is consideration of the GAM, general additive modeling. This smoother term is important for the modeling. We can also understand it like that. This, as I mentioned before, and if we see the p-value, persons assisting are important, and the survey year, interaction with the survey year and site alone, and site and year, and survey ID. Survey ID means in one site if we have many surveys, then one site has one survey has one survey ID. It means that, so if we do age survey, we have 1 to 80 numbers like that. And it's very complicated, seems complicated statistical result. So just we have to understand this point, what variable is important for this total count of debris. Similarly, in the table 2, we have a similar thing. This is for accumulation survey result, and this is for standing stock survey. Only for Greater Parallels National Marine Sanctuary, lower part, I mean, on the coast of California, and likely, if we see p-values, these variables are important, significantly important, and influence significantly on the total count of debris. Here, for total marine debris item count and type, season, and nearest town distance, if the site is near or far from the site, and the nearest river distance. It means same thing, is near from the site. I mean, the site is near from the river or not, and the type and season. It means interaction between type and season, and it means interact each other between type and season. And even although we don't understand very well about this, we can understand that these two terms interact together and influence the total debris, total count of debris. And smoother term, to make the line smoother for like three-dimensional, not linear graph, then we have to make the line smoother for the model. Then for that, for the purpose, this term is important. In this table, debris type are written like lumber, plastic, and unclassified debris. It means survey, interaction survey and type influence the total count of lumber, and this influence the total count of plastic, and this are significantly important for unclassified debris. And beach width was important, and persons assisting. It means surveyors, the number of surveyors, and year and survey ID. I highlighted with a pink color for the variables. And this is a seasonal trend, year trend. Linear trend for the debris change, and for, I mean, it's for year, total year, and for plastics and for this, each sanctuary, plastic debris decreased 44%, 0.2. So plastic decreased this amount in greater tolerance, and we can understand this model explains very well because it's 82.6%, and in for Olympic coast for the debris, it increased, and fishing gear debris here, California coast decreased almost half, and for Olympic coast, I mean in Oregon State, it decreased this amount. And we have, if we see the p-value, this is significantly decreasing, and it's not, and it's significantly decreasing, and this is not. So for this value and this value in Great Parallel, plastic debris and fishing debris decreased significantly, we can say that. And this figure says about the table, this figure, and it's not decreasing, or little increasing, decreasing, and it doesn't show the trend, and it shows the trend clearly. And this is this area, Great Parallel National Marine Park and Marine Sanctuary, plastic items through standing stock survey. If we see the result, it says a smoother trend for standing stock survey. This area, this is easier to read this sentence. I mean, if we read this sentence, it's easier to understand. 1.2 represent unexpected count, 20% higher than average. It means this line means average, and it's below than average, like this season, like 20% below than average. And this line, if this is 1.2 here I think is 1.2, because it's this line is 1.25 half. So here like 30% or 25% increase in this year, this period, and here maybe summer season and winter, the early of 2015. We can understand like that, and we can understand that this line shows the trend of the debris from standing stock survey. And with table 4, we can understand seasonal comparison of estimated plastic item count within 2 regions. This is for accumulation survey, and this is for this data for they obtained the result from standing stock survey. And we have two regions. One is here and one is here. And below this line for OC coast, OC sanctuary, and this line for GF sanctuary. And p-value, well, anything is not important for the debris. And here for Olympic coast, winter, and so if we compare winter count of debris, plastic debris here, plastic item count, winter and summer are different significantly. Winter were higher than summer. And here, winter and fall. Winter is higher than fall, and it was significant. It means we can definitely say winter debris is higher than summer and fall. And for other seasons, it's not. It didn't show us the seasonal difference. And for this region of for two region, between two region, for the total count plastic debris in fall are significantly different, and for summer and spring. But in winter, it didn't show the significant difference count of plastic debris. And for standing stock debris, for this region, I mean, we upper region, GF NMS region, and the debris in winter is significantly higher compared with fall and spring. Fall, winter and spring were higher, and fall, summer lower. I mean, the debris of fall, debris of summer or lower, and debris of winter and debris of spring was higher. Then these fall comparison were significantly higher here and lower here. And is a plastic item for through accumulation survey. And we have to see this line: purple winter, green spring, blue summer, red. Oh, okay. Okay. And for this region, debris is significantly decreasing. I can say I don't remember the table. If we say it's significant or not, we have to refer the table, the number p-value. Anyway, it's decreasing pattern. And here, we cannot say it's decreasing. And here, increasing and decreasing again. And it's increasing and totally, what did I say? Increasing or decreasing?
No trend, no significant trend.
And one was decreasing and one was increasing, right?
So
we can say no significant difference. And here, for standing stock debris, I told you winter and spring, the debris of winter and spring were higher than spring, summer and fall. We can see this line is upper and lower. So we can understand that thing. And second, we can see seasonal difference and yearly difference, yearly trend equals seasonal. I'm sorry, temporal trend. Temporal trend here decreased and increased again and decreasing. And here fluctuated. We can say safely just fluctuated year by year. And this figure says beach width, how long how long the beach width was for each side. They modeled for plastic item here, plastic item counts versus beach width. is increasing with the beach width, and this slope higher than it looks higher than this area. And the content says, as I told, it means if we survey more than 60 width of the beach, the debris increased a lot. It's controversial for my understanding, because if we start a survey from the backshore to the waterline, and if the beach width is increasing, I'm not sure the debris is increasing, but they said like that. Beach width increasing, the total plastic count all increasing, and the trend is more. The trend is significant or 심해진다고. This is severe for this beach width is larger than 60 meters. So we can discuss this about my presentation. I don't understand this point of them. And this is for person, right? Person. We can understand with this figure. They mentioned 5 person. Anyway, the trend is steeper here. It means if the survey persons, if we have more persons up to 5, we can collect more debris. The debris count or increasing. But if we have more than 6 or 7, 10, the trend also slowing down like that. I mean, if we have 20 or 30, we don't survey 2 times or 3 times of debris. It's definite, because between 5 or 7 people, we can collect all of the debris. So more than, just imagine if with 5 person, I collected all of the debris on the transit, I don't need more person. It means that. So the last of the table and figures. And all of the result I told you with the paper, so I just skip that part and go to the discussion part. This is the map of the survey site. And I wrote down the importance monitoring, but I think almost all of us understand the importance of monitoring. We have to monitor because of the management of marine debris. That's all. And NOAA MDP is MDP means Marine Debris Program. Under this program, they have Marine Debris Monitoring and Assessment Project. It's called MDMAP or MDMAP. And with this program, they surveyed from the early of 2010. And they studied the data from two national marine sanctuaries. And here I'll tell you brief for the standing stock survey and accumulation survey. A standing stock survey for rapid quantitative assessment, the debris was larger than 2.5 centimeter. And for standing stock survey, they surveyed 4 5-meter transit, randomly selected for 5-meter transit. But for accumulation survey, they surveyed the entire area of 100 meter of the site. And for standing stock survey, they didn't collect the debris, and for accumulation survey, they collected. And the interval was 28 days. It means once a month they surveyed. And they classified the debris A material-based, not source-based, material-based like plastic, lumber, paper, and metal, and others unclassified like that. And they further identified the debris into 46 items. And one specific thing is they can add customized debris. If we have something special debris in Tongyang, if I survey in Tongyang area, I can add some special debris on the data card, and I can upload the data into the database. So here they added 2 items like shotgun wet and farming oyster debris. For this, they trained volunteers. And for this region and this region, the survey point were different and the survey were different. Here, they have sand beaches, rocky cliff, something like that, but they choose sand or pebble beach. And this area, GFNMS, they surveyed the standing stock survey and accumulation survey. But OCNMS, Olympic Coast, National Marine Sanctuary, they surveyed just for accumulation survey. And the year was different. For standing stock survey, from 2012 to 2018. For accumulation survey, from 2015 to 2018. For site, for standing stock, to site for accumulation survey. And persons were different. For GFNMS, 3.8% for accumulation survey, 2 participants for standing stock survey. It's average, and the National Marine Sanctuary staff periodically join the survey for quality management of the data, and they wrote down the data on the paper card, and themselves can upload the data, or then they send the data card to the National Marine Sanctuary staff, and the staff uploaded the data. Similar thing, almost was similar to the Great Perilon National Marine Sanctuary in Olympic Coast National Marine Sanctuary. The difference is in Olympic Coast Sanctuary, they surveyed accumulation survey and the period from 2012 to 2019. And survey site was a survey was different. It means in some site they surveyed every month, but in some site they surveyed just a summer or just winter. We don't know. If we want to understand that point, we have to see the raw data. Anyway, the surveys were different from site to site. And they added 22 local items like plastic oyster farm debris, plastic shotgun wet, or plastic shell castings, firework pieces. They added a lot. And participants were averagely 2.8 persons. And last things were similar. And data management, they manage the data with the database. And as I told you, surveyors can upload the data, or the National Marine and Sanctuary staff did that. And the NOAA staff checked the data for verification of survey data. And statistical method, they made a model of generalized additive models, and they made a linear model. And this part I'll skip because many variables are important, and I think we just have to understand the table thing. On the table, there are many variables, and some variables were significantly important, but others are not. And for total debris from standing stock survey, they made a model with many variables, and they select best fit model with GAM. And it means this variable is important and included to the model. Debris type, season, nearest town, nearest river, and debris interaction between debris type and season. And for plastic only, debris type, season, nearest river, debris type, and season, and smoother terms, survey year, debris type, survey interaction with survey year, nearest town, which width, number of person, and random impact. And I think this part is important, more important for us. Annual trend of plastic was negatively linear for accumulation survey and standing stock survey for longer period in the Great Farallon National Marine Sanctuary. But for plastic debris, non-linear relationship was observed between 2014 and 2016, and is this relationship came from temporal peak, initial high debris load. Initial high debris load means for accumulation survey, we have more debris because second debris, first debris we collected, removed the debris from the site. Then second debris, we probably have less debris than first debris. And temporal peaks means some season we have a lot of debris, and some season it decreased. We did see this kind of result with a figure, and it reflects patterns of coast upwelling and downwelling in the region. In the abstract, the author says about this impact. I don't know about this oceanographic thing, but in the contents, they says spring and summer upwelling occurred around the coast of California, and winter downwelling occurred from the south, and winter the currents goes to the coast and upwelling from the bottom to the coast and turn around to the outward. So debris accumulated to the coast. That part I understand. So it influenced the debris count. And I told you that this figure with the table decreasing and decreasing this area, but other area we didn't see the trend. And here in this paper, important thing they says no significant trend was detected in Olympic Coast National Marine Sanctuary for accumulation survey for little plastic or fishing related debris. This trend, they says, trend is worldwide. Even 10-year survey or 26 years survey in North Sea, they couldn't find any significant trend. And in the paper, with less than 20% decrease or increasing, we cannot understand. With larger data set, it means if we want to see the trend, the difference should be larger than 20%. It means for 10 years, the debris should be increasing more than 20%, or increasing more than 20%, decreasing more than 20%. Then we can see the trend. But like a 15% decrease or 15% increase, we cannot see with a larger set of data. It was new to me, and I think it's very important point. And survey effort, they used a log linear relationship because debris count was has very variability. That means the debris count were very variable from survey to survey. We understand because we saw many times the heterogeneity of the debris. So I told you this, we have to understand we should have big data and big difference between the survey data if we see the trend. And in this discussion part, they says plastic dominant is consistent with other global data, and higher in winter, spring, and lower in summer and fall. And trend, I told you already. And so sampling days, some sampling width, we checked this point, and survey interval. And as the survey interval increases, the amount of debris observed increased. And turnover rate of debris observed in this area were much lower than those reported from previous work. And they mentioned about anthropogenic influence, but this 1, 2, 3, 4, these 4 they could not detect. They are anthropogenic influence, substrate type, characteristics of a monitoring participant, and the federal land management policy. I'm sorry. These 3 things doesn't influence on their data, but they had federal land management policy. They closed oyster farm in the sanctuary, and the debris decreased for this point, 37.5% from 2012 to 2014. That this period to this period. And they had targeted marine debris prevention initiatives. One is shotgun wet in Great Farallon National Marine Sanctuary, and they had a pilot campaign, and this influenced their data. That's all. These are all about my presentation. If you have any questions, please.
Thank you, Jong-soo. Do you have any question or comments about this paper? No?
Yes, if I may.
Yeah, Jerry, go ahead.
So it's so technical for us to really understand fully the paper. But anyway, it was a good. It gave us a view of what seasonal factors are in the US. While in the tropical countries like Philippines, we are doing the important factors are the monsoon winds. In the paper that was presented, that you presented, it was more of the seasonal aspects, and winter was the most significant season where accumulation surveys and the data were all there. You know, it's high during the winter season compared to the other seasons. So I appreciate the presentation, your presentation, since it gave me a view of what the Western Hemisphere is experiencing for accumulation of debris. But basically, yeah, I had to read more of that paper, which I downloaded anyway. So thank you for your presentation. I really appreciate it. Thank you. Bye. That's all.
Okay, hi Jerry. As far as I understand, you mentioned about the temporal trend and
Yes.
monsoon season in California. They have very less rainfall. It's a dry area, and I mean they don't have monsoon season.
Yes, I
and
know.
In Oregon State, usually they have 30 days, 300 days, rainy days. I heard just except 2 months or 1 month they have rain. So the monsoon season or not is not important for those regions. And
Yeah.
I mentioned before, the upwelling and downwelling are more important for their debris trend.
Yes, yes. Thank you. Thank you.
Any other question or comment? Jongsu, you can Google downwelling, and we can see the mechanism of movement of seawater and the wind.
Right now?
Just the downwelling.
Downwelling here?
Yeah, in Google. You can find the images.
Downwelling.
Okay. At the meantime, do you have any other comment or question? Yeah.
Yes, Dr. Lee. We don't have downwelling, upwellings here in our country, in I think in Asia. Not
Yeah.
much pronounced downwelling or upwelling. Unlike in the temperate countries, it's more
Yeah.
pronounced, and it is a very good, a significant thing for temperate countries because it sort of puts up all the nutrients, the good cycling. You know, that's it.
Yeah.
This is the wind-driven downwelling that I also know from the temperate countries. Thank you.
Yeah, thank you. And you can see the figure depicting the movement of seawater and wind when the downwelling is happening. So this kind of situation is very good explanation of debris movement, especially in North America. They have a unique this kind of movement, so we can understand that debris at the surface, on the surface of the seawater, it will move from offshore to the shore. So it will make a accumulation of debris on beaches. It can explain the seasonal difference between this survey result. Okay. Any other question or comment? Okay. No more question?
Yes.
I think we have to read and read again the paper because
Yeah.
you know while she was able to point out the important things there in the paper.
Yeah.
I think I'll have to go back again and read and read the paper.
Yeah.
At least she has opened some of the aspects of the paper, which is significantly I appreciate really. Thank you.
Actually, I have too many things to discuss with you, but yeah, many tricky discussion point from this paper, but I think we will have another chance to check the monitoring methodology and result at the later next time.
Yeah.
But one thing I want to point out is that there are too many variables in their model, so it's too complicated to understand. So in this case, we can apply some kind of a multivariate analysis, like MDS or principal component analysis. That kind of approach can make some mixed explanation with the combined factors combined to explain the difference between the monitoring result. That is one thing I want to point out. And
Yes, Dr. Lee, and that's also, well, the title itself is for citizen science, and I think it is, as we are scientists in a way. I have my background on that, but for citizen science, I think this is complicated.
yeah,
Yeah, thank you. Yeah, that's
thank you.